So, hello everyone. Today I'll be presenting a C program that performs several string analysis tasks. The program allows the users to input a line of text and then it analyzes the text by counting visible characters, words, vowels, consonants, checking the matching first and last words, palindrome detections, and reversing the string. So, let's walk through the code and understand how it works. First is we are going to include libraries and define constants. First, we start by including standard libraries such as stdio.h, string.h, ctype.h, and stdboolean or the stdbol.h. So we use stdio.h for input and output, string.h for string function, ctype for character checks, and stbol for using booleans to identify if it's true or false. So is we define max length as 201 to allow room of null terminators. So here we have a defined helper functions. These functions abstracts repetitive logic, which is the bool is letter to identify if the characters are letters, and boolean is vowel to identify if the characters are vowels. So now we are going to proceed to our main functions. So here we have first we have to print the total number of visible characters in the line. So that means counting every characters that the user enters. So including spaces and punctuations, but excluding the new line from pressing enter. So here the program will read the numbers of words characters including space and punctuations except new lines. So to do that, first we have to ask the user to enter a line of text up to 200 characters. We use fgets line max length stdin. For this, for the fgets, we use fgets to read the line from standard input, and max length is a set of 200. We set the max length to 201 so we can hold 200 characters plus the null terminators. Next is after we input, after the user inputs the lines, the program will calculate the actual length of the string that the user enter using size, the length, string length, and line. So this gives the number of characters in the line excluding the null terminator but including the new line character if the user pressed enter. So because fgets includes the new line character at the end, so we need to check for and remove it. So we use if length is greater than 0 and line length minus 1 is equals the new line. So this will include the new line. These steps replace the new line with null terminator and adjust the length accordingly. This also makes our string clean for later processing. So next is now that the new line is gone, so we know that len is the number of visible characters like letters, digits, punctuations, and etc. But we must also count the null terminator, so we add 1 to len here. Adds to 1. And then so just like what I have said here, so after that we print the total visible characters. You also have to note that the code provided does not add one to land when printing. If you want to truly follow the instructions and include the null character or null terminator, then modify this line like so. So print, you have to print total visible characters, then length plus 1. So we have this. So that is the first step of our code, which is to print the total number of visible characters in line. The second task is to count how many words in line contains. To count how many words the line contains. So we need to count how many words are there in the line. According to the problem, a word is any sequence of consecutive English letters, either uppercase or lowercase. This means that words are only made of letters. Words should only made of letters. Any non-letters like space, punctuation, numbers, symbols will be separate in one word from another. So yeah, it is another. So to do that, we have to go through the string one character at a time using loop. So we're using loop here. So that before the loop starts, we define variables into int word count equals 0 and boolean in word false. So word count will keep track how many words were found, and in words will help us track whether we're currently inside a word or not. So inside the loop, we check each character. So if is letter, see. So we use the helper functions is letter to check if the current character is an English letter. So either uppercase or lowercase, it doesn't matter. So is letter is defined at the top. Boolean is letter character to define if the character is English letters. Next is, so since we are, so if we are inside a letter or word, so we have the function here if not equal, if we are inside the letter of word, we have a function here. If in word is false, meaning we were outside a word and we found a letter, so it means we're entering a new word. So in here, the program will count. No. So if in word is false, meaning we're outside the word, so even if it is a punctuations, spaces, symbols, numbers, it will count separately to the word. So that is so we increase word count by 1 and set in word equals true to mark that we're now inside a word. So next is if the character is not a letter, we leave the word. So else in word equals false. So any non-letter character like space, number, comma, etc. ends the current word. So we set in word equals false. So we're ready to detect the next word. After the loop finish, we now know how many words there are in line. So the program will print it. So printf word counts, and then it will display how many words are there in line. So next is our task 3, count how many vowels and consonants appears inside those words. So after counting the words, we are now asked to count how many vowels and consonants appears inside the word. So this means we only count letters. We ignore punctuations, digits, space, or other characters. We must distinguish between vowels, which is A, E, I, O, U, and consonants, all the letters. The check must be case insensitive, so it doesn't matter if the word is uppercase or lowercase. So before looping through the string, we define two counters. First, int vowel count and consonant count. Vowel count will hold the numbers of vowels found. Consonant count will hold the numbers of consonants found. So we already defined this line earlier when we declare word count too. And just like here above, beginning so word count. The difference is in the word count, we the program will count even null characters, punctuations, commas, spaces, and other characters. But here, only vowels and consonant letters the program will count. So here, so we are going to continue using the same loop from the task 2, which is counting the word. So the for size the was. Then for each characters, we check if is letter. So if the character is a letter, it is part of a word, so we must check if it is a vowel or consonant. So to check if it is a vowel, we use these helper functions. The boolean is vowel, character C equals to lower, C return, C is equals to A, or C is equals to E, or C is equals to I, and etc. So on and so forth. So this converts the character to lowercase using to lower C, so that big letter A and the uppercase A and the lowercase a are treated the same. Then it checks if it's one of the 5 vowels. So inside the loop, we write if is vowel C, a vowel, count plus plus, else consonant. So if the letter is a vowel, increase vowel count. Otherwise, it must be a consonant since it's still a letter. So we increase consonant count. This checks is inside the F as letter block, so we are sure that only alphabet letters are being counted. So after the loop, we print the result, printf vowels and consonants. So it will display the numbers of vowels and consonants from the user's input. So now we proceed to task 4. We're going to check if the first and last word are identical. Case insensitive also. It is also case insensitive. It's either uppercase or lowercase. If the last words, first and last words are identical, then it will read. The program will read. So now that we have counted words and letters, the next task we are going to do is to check if the first word and last word of the line are the same, regardless in case. So important rules, only letters, the same letters, A to Z. So any character that is not a letters, such as spaces, functions, punctuations, and etc., separate words. So we need to ignore case. So hello and uppercase hello and lowercase hello are considered the same. So to do this, we are going to create 2 character array to store them. First character, first word. We have and last word. So these arrays will store the actual text of the first and last word. So we have here 50 characters. We use 50 characters since no single word will be that long. So we also prepare int index equals 0, boolean and first equals false. So the index helps us store characters in the first word array, and in first helps track if we're currently inside the first word. So now we extract the first word from the line. We can we scan the string from the beginning using a loop. So we're using a loop here. Then we go character by character from the start. If this is a letter, we convert it to lowercase using to lower. So comparison is case insensitive, and store it in the first word. Set in first equals true, so we know that we're still inside the word. And if we reach a non-letter character, no, if the program will reach a non-letter character after having started a word, it means that we've reached at the end of the first word. So we break the loop. So the program will break the loop. So after the loop, the program will terminate the string properly. Here, first word, index. And then now we can scan the line in reverse from the end. Same. We have also the loop here. We move backwards from the last character to the start. We again look for letters. As soon as we find one, we start storing characters in last word. But since we are moving backward, the word will be reversed when stored. So after storing, the program terminates last word index equals null terminator. But since we built the word in reverse, we must fix it. So we have this string rev last word. It reversed the string so we can compare it correctly. So now both first word and last word are lowercase, properly stored and ready to compare. So we used here the string compare, first word and last word. So this compares the two strings. If the result is 0, then they are equal. So we print first and last word are the same. Yes, or it will answer or display yes or no. And next, task 5, remove all non-letter characters. Convert the rest to the same case and check if the resulting string is palindrome. So a palindrome is a word or phrase that reads the same forward and backward, such as madam or race car. So in this task, we are going to remove all characters that are not letters, so spaces, punctuations, numbers are ignored. We convert all letters to lowercase to move comparison case insensitive. And we then check whether the cleaned up string is the same forward and backward. So we declared character filtered, then the value 201 reversed. Filtered is hold only the letters, all in lowercase. Reversed will be a copy of filtered but reversed from comparing later. So we also prepare an index, and f index equals to 0. This index will help us insert valid characters into filtered. Now we loop through the original line to filter letters only. So we're using loop. We go through the string character by character using a for loop. So for each characters, we check if the letter is using we check if it's a letter using S letter. If yes, then we convert it to lowercase, or the program will convert it to lowercase using to lower to make it case insensitive. Now store it in filtered and move the index forward. After the loop, the program will terminate the string. So we have here filtered f index. So this ensures filtered is a proper C string. So now we are the program will copy and reverse the filtered string. We have here string copy, reversed and filtered, string reversed. So string copy will copy the filtered string to reversed, and then the string reverse the reversed string in place. So now comparing the string to check if it is a palindrome. So in here we have string copy filtered reversed. This checks if the filtered string is the same as it reversed. So if it returns 0, it means they are exactly the same, and therefore it is a palindrome. So the program will print palindrome, and it will display if it is yes or no. So now we are going to output the entire original line in reverse order, character by character. So in this task, the program asks to display the original line in reverse order, but not by words, rather character by character, including spaces, punctuations, etc. So we already know length of the string, which is the length from earlier. Now we simply use loop that starts from the last character and goes backwards to the first. So this loop. So the for loop starts at I equals length minus 1. So this is the index of the last visible character. And it ends at I equals 0. So the index of the first character. Then put character lines. It prints each character one by one. So we use put character instead of printf for efficiency and simplicity in printing single characters. And then return 0 and done. Now we are going to run it. Wow.